Thank you much. First of all, welcome everybody. My name is Dan Backman. I work for Cisco Systems. I've been at Cisco for about 7 years now. Before that, I've been a few other places. I've worked in data center technology at a couple startups, and before then, I worked for a company that makes routers and gin flavoring. And I have enjoyed a few sessions here at TFT before, but I'm super excited to talk about what we've been doing for Hyperfabric. Just as a little bit of background, this is a product I've been working on for about 2 years now. We've spent a lot of time working with real network engineers, people like yourselves in the trenches who are building out large networks. And we've literally started looking at how do we rethink the operational model of running a data center. I'm also joined by my colleague Minako, and Minako is one of our awesome TMEs, just one of the best group of people that I've worked with. We've worked very closely with our DC group as we've been putting this together over the past years to make sure that this is an awesome session. So Minako is going to walk us through a lot of the functionality of this, and likewise, we are also going to show you a live demo, because in the end, that's what matters. You can listen to me all you want, but let's actually see exactly what this looks like. So first, let's take a look at what Hyperfabric is. You can see clearly what's in the title, but first of all, what exactly is it? I really have to start by saying, I can't believe Cisco let us build this. This is awesome. This is a cloud-controlled data center fabric running on switches that are purpose-built and hardened for deploying data center environments, running Sonic.
Hedgehog?
Mm-hmm.
No, just Sonic.
Not the gene. That's also a Sonic the Hedgehog. But actually, no, we're actually running a completely new operating system. When we built this, we had a chance to go back and look at if we were going to solve a lot of the operational problems that we had running networks, what would we do? Number one, if we start looking at data center fabrics, data centers should be a science and not an art. How do you make a reliable data center? It should work the same way every time. We're here at Cisco Live, so if you go out on the show floor and you were to go pick up 5 CCIEs and put them in a lab and give them a whole bunch of switches and tell them, I want you to build the data center fabric, what do you think is the probability that the configurations they put together, even though they're all awesome, they're going to make it work perfectly, what is the probability of those configurations being even close?
0.
Probably. They might choose the same protocols, but even then you're not sure, right? So one of the things we looked at is there are best practices for how you run large scalable data centers. And we learned a lot from the hyperscalers and said, if you're going to run a highly stable, large scale data center, what would you do? You would make it very repeatable. You would want to make sure that none of these deployments are a snowflake. And we want to build an architecture to actually help our customers build these types of fabrics. The other things we would want to do are make a fabric not fragile. Data centers are critical infrastructure, and one of the problems we often see is once you build that network, people are afraid to touch it. If you're going to build a data center fabric, and let's say you want to go expand it, if you're building it on a typical fabric technology, in many cases, you may actually have to go back and re-architect that because you have to think about all the different layers of signaling protocols, reachability that you have to rebuild. How do we actually change the experience of deploying this? And that's what Hyperfabric really is all about. So if you were going to build something like this, what would you do? You would start by looking at how do I change the control plane so that I can make it plug and play? How do I look at the operational model? And maybe even look a little further than just running a fabric and make it something that we could actually start to eliminate a lot of the frictions you get when you typically deploy a fabric. And then you would want to make it repeatable. You'd want hardware that always works. You want something that could actually solve this problem of running large numbers of data centers in distributed environments, solve that edge compute data center problem. And if you were going to do that, what would be all the pieces you would put together to build that? That's what we had the opportunity to do 2 years ago. And we've been working on this. We are super excited to talk about it. And with that, let's go a little further and take a look at the actual product.
Okay, so the first thing we're going to do is going to hyperfabric.cisco.com. It's already public. You can reach out to the URL already, but unfortunately, you cannot log in yet. It's going to be available next month. So the first thing we're going to do is by using Cisco account to log in to the cloud-based controller. The customer doesn't have to prepare on-premises controllers so that they can easily try it out. The first thing we're going to do on the cloud controller is creating Fabric. So imagine you have a new project deploying Fabric. What is the typical first step? So let's walk through how it would look like in Hyperfabric. So hey Dan, how big your fabric would be? How many switches we need?
Let's make a leaf spine. How about 2 spines and 8 leaves?
8 leaves.
Notice as Minako is building this, the whole point of the designer is we want customers to actually interact with this. We want people to actually get guided into what is a valid design. The whole idea of Hyperfabric is also, there is no Cisco validated design for this. This is actually built into the designer process. Now what you see is we've created a blueprint for that fabric. Now that blueprint has the switches that you selected. We now know the size and shape of it. But where else would we go with this? What's the next thing you would do, Minako, if you're going to build a data center fabric?
I probably need to define how to connect them each other by checking what's the required speed and what's the optics supported on the devices. So probably people need to take a look at data sheets of each vendor's switching network devices. And also open up some famous application called Microsoft Excel or some sheet kind of application to list up the cabling plan, because I'm probably not the person who's going to cable it. Here, the interaction happens, and then sometimes we might make some mistake, right?
So how many people here have built that Excel spreadsheet? That sheet that shows every port that goes to every port. We've all done it, right? This is actually the joke that happened. We've spent a lot of time with real network engineers as we've been building this product. And the joke that kept on happening is, what's the #1 most used tool in network engineering?
Nobody liked that.
Precisely. I thought it would be SSH, but no, everything comes out to an Excel spreadsheet. So what this highlights, though, is that as you're building networks, what we do find is that there's a bunch of places where you run into friction, because the people who design a fabric are sometimes not the same ones who actually deploy the fabric, and then they're not always the same ones who actually operate the fabric later. We rebuilt this controller, and with a web presence, what we can do is start to rethink how we can get these different groups to collaborate together and get the right answer the first time. And that became the backbone of how we actually built and managed the fabric. So let's go ahead and build a cabling plan.
So how many cable do you need for each switch pair?
Well,
Between
2 by
leaf and
8.
spine?
Yep.
So let's say 1 link for each pair. And then what's the speed do we need? So let's pick 400G. Then what's the cabling type do you prefer? Depending on the data center, facility, there might be a requirement of multi-mode or single mode. So the system is going to tell us what's the available optics based on your requirement. So let's pick this SR42. Then, boom. You don't have to deal with Excel sheet. So it's going to create a list of cabling plan. So let's take a look at the first example. So how would you connect spine and leaf topology? It's most likely you're going to pick the first fabric port of spine is going to first fabric port of leaf 1. And then continuously doing this, and then managing this in the Excel sheet. And as you may probably notice that is a cabling plan that is exportable. And if your field technician has an access to the system, you guys can share that information together. So Fabric Blueprint is a source of truth, not only just a logical configuration, but also cabling plan.
So why did we do this? Who here has gone into a deployment where you've built a design, you've figured out all the pieces and parts you need, you order the gear, and then maybe a month later, you're sitting in the data center and you're plugging in all the gear. And you figure out, oh, these leaf switches are rear mounted in a rack. I need the airflow to go the other way. Does that ever happen?
Never happened.
Or I ordered a whole bunch of multi-mode optics, and as soon as I go plug it in, they're oddly blue colored, and realize, oh no, that's single mode. So that's a problem that happens a lot, believe it or not. And it doesn't matter how good network engineers and partners are as part of this. Mistakes like this happen. So we all spend lots of time on the internet. What is the right way to get the correct answer to any question on the internet?
Ask a chatbot with AI, or?
Well, that's the 2025 answer. But before that, the right answer is you post the wrong answer on a chat board, and the entire world will correct you and tell you the right answer. We can do the same thing here. So what we showed you is actually that Excel spreadsheet that you would normally build, but we're populating it with all the information about the optics that you need to know. And it's maybe not that you need to know it, But now you have a sheet that you can hand to the physical layer team in your data center that says, I'm going to build a fabric from these racks to these racks, and I'm assuming that I'm going to use multi-mode fiber, and we even print out what is the max supported distance on that type of fiber with that optic, so that your physical layer team now at the planning stage can tell you, oh, that one rack is actually over there, and it's more than 200 meters away, and maybe you need single mode for that one rack. So now you can actually get the right answer for the physical layer team because you've already given them the plan before you order the gear. This is why we built this. The other thing that we're doing is this now becomes source of truth for the controller, which we'll talk about in a second. The next part is you need to order the gear too. So why do we have to go call up somebody and have them do a quote for us and go do a configuration where we already know the right answer? We know what switches you picked. You picked the airflow, we know which airflow direction it needs to take, and we've already picked the optics. Why can't we just click print? Well, we can. And we're also adding a button that's going to connect directly back to CCW so that we can actually generate an estimate for you right away. Now, if you're working with a partner, the other part of this is a website. This is a web-based controller. You can invite other people into this. So you can actually take your SE or your partner or your trusted partner and actually invite them in and collaborate on this design as part of this. This is a slightly different take on running networks, but as we started looking at a lot of these headaches that you often run into, there's real issues of when you show up and you got the wrong optics. Hey, 400 gig optics. First of all, they get kind of interesting once you go past 100 gig. There's a lot of options. You even need to start worrying about whether it's angle polish or not in single mode. And then at the same time, you need to worry about a whole lot of other factors. So it gets complex. So how do we actually get the right answer and get all this built right the first time so that you don't actually have to wait if you got the wrong optics and order new ones? That can delay a data center deployment by literally weeks to months.
I know you have heard this before, but the order button to the Cisco web shop would be nice beside the print, yeah?
That would be great. Cisco doesn't make it that easy to do business. We wish we could do it.
Cisco Connect.
The best we can give you is an estimate where you can connect directly, but yeah, we would love to be able to do that as well. The other point is, we also have this information, so now we can start taking this and give you different views of this. This is an assembly list. Like when you get the gear on-prem, how do you know you got all the right pieces? How do you know where you're going to plug in all the optics? We're actually putting that information forward here as part of that same view. So, we're going to pause there for a second. We're talking about a data center network. We haven't got into any gory details, but it sure looks like a pretty cool configurator, doesn't it? Well, it's actually the controller. This isn't a configurator. It's actually the source of truth for the controller that will actually be building and running your fabric as well. So, what did we cover here? What is different about Hyperfabric? We've looked at how do we build the network experience, but take a step back and actually try to incorporate lifecycle, because it matters. This is where you run into real problems. And if we already know the right answers, how do we connect the people that need to know so that we can get the right answers all the way through? The next piece is, right now we talked about day zero, sort of the planning stage and the ordering stage. But how do we continue this? Wouldn't it be great if we also took this information and helped you on day one when you're physically installing it? We'll talk about that in a second. The other piece is we also to extend it further. This is not just about deployment. This is also about life cycle of running a fabric. That means we also have to do things like software upgrade and maintenance and changes to the fabric. We want to help you actually deploy it, but also make changes in the future and make those painless and seamless as well. So this is really what's different about Hyperfabric is we're looking at this end-to-end life cycle of the fabric and trying to leverage this as a source of truth throughout the entire system. So what are the other pieces that we need? We need to actually also take this and build a fabric that now becomes much more easy to deploy and much more flexible. Let's take a look at a little bit more of this. We talked about the bill of materials. We are going to build a connection to CCW so you can get the estimate.
So how's it done into the CCW? Is it like through the export CSV and then you import in the CCW? Or?
Oh, we're going to make an API connection. We're exporting a CSV today. We haven't enabled the button yet that will actually generate the estimate. We made some changes in PID, so we have to make some updates before we release it. But it's actually going to be a button that says generate estimate. On the back end, we will take that BOM that we have, including all the software licenses that attach to this, which is actually a very simplified model. I think you'll like how we're doing licensing. All of that gets automatically sent into CCW, and it generates an estimate. And the estimate is something that you can share with a partner where they can go figure out what the pricing structure you'd offer. So as a customer, if you're not a partner, what you would get is an estimate ID. We can email that to you, or you can give it directly to your partner. If you're a partner, then you can get direct access to the estimate and generate a quote directly.
Perfect. Thank you.
The other thing that came up here with all the network engineers that we've been working with is there's a real desire to start to make these networks self-documenting as well. If we can establish the controller as a source of truth, why can't we just take that and emit that information? You start to see that with things like selection of the pluggables, where we're automatically deriving information for the pluggables that you need. Likewise, the actual interconnect matrix. By the way, it's smart enough to also deal with things like breakout cables. We spent a lot of time making sure that this actually works and scales for the different deployment types you need. But we also add something else, which is a day one feature. So one of the biggest problems that you have when you start deploying this is somebody's got to physically plug this in. Who's been on that call where you've got remote hands in the data center, they're on a phone, there's really loud fans behind them, and they're sitting there plugging in cables, and you're sitting there looking at the console. And the first thing you say is, all you hear is, what about now? Nope, didn't work. How about now? Who's been on that call?
Yeah. Lucky you if they are speaking the same language like you.
Exactly. So if we have a cloud presence and we have a source of truth of where every connection should go, and if we have switches that call home to cloud, why can't we make this easier and just tell people what to do? So we've also built in a remote hands interface into Hyperfabric. This is something where you can take a cell phone, and we assume the person whose remote hands doesn't work for you. You can invite them in, you can give them a link to actually join this fabric, and it will give them a list of tasks. Here's all the things I need you to do. I need you to get these switches plugged in, connected to cloud. And we'll talk about how that works as well. And then here's all the things we need you to cable in. Day one is a lot of plugging things in and cabling it, but that's where a lot of mistakes happen. We'll talk about in the future why this gets even worse. Even for the fabric we just built, that's 32 separate links. And when you consider each one of these is probably going through structured cabling, and you could potentially have polarity problems all the way through, there's a lot of trial and error here. But wouldn't it be great if they had an interface when they plugged in a cable and they saw link go up, if we tell them, did you plug into the right port? Did you plug in the right pluggable? If we know that's supposed to be a 400 gig single mode interface, but you plugged in a multi-mode interface, we should tell them immediately, because maybe that was intended for a host instead of a fabric link. If link came up, the next thing you want to know is, did it come up to the right place? Is that fabric link actually between the right two switches? And did it land on the right ports? And even if it comes up and lands on the right ports, we can then give feedback to say, no, this came up, but this is wrong. I need you to move that from this port to this port. Why can't we do that? It shouldn't have to be this hard. So this is also built natively into Hyperfabric.
One question for the screenshot. Do the smart hands interface also show the physical view of a switch and highlight the port in the fashion?
Yep, we're still doing some updates. That's a mock-up. One of the things we are actually adding is a physical view, because you're right. Why is it that every switch, sometimes the ports number top down, left, right, sometimes left, right, top down? It's a little infuriating.
Yeah, often the interface names for networking person, it makes sense. For smart hands person, maybe not. Yeah.
I'll tell you a little secret. As we were developing this, we're using hardware from a couple different business units to put this all together. And what we learned is that in some parts of Cisco, ports start with a 0, and in other parts of Cisco, ports start with a 1.
Yeah. Best is bring some kids. Everybody brings their 6, 7-year-old. You try it out. It's working with them. Then it's good. Yeah.
Absolutely. I love it. And the other thing here is that this is not an app. We don't want to force anybody to install an app. This is a mobile responsive web page, which means that we can make updates to this. You don't have to. You just have to hit a URL. You've got access to this. And then there's only limited things that you're allowed to do as a smart hand. One of the things you can do, for instance, is there's a portion of sort of claiming a switch and binding to a fabric. We're enabling limited read-write access so you can accomplish those tasks as smart hands as well. So we spent a lot of time on this. We're really proud of this feature. We think this is going to be a really important thing.
I think Dominic had a really interesting point. And I definitely seen that. So, you know, sending switches to remote sites where there are no available English speakers. Like if you would translate this into like, you know, local languages, that would be huge. Because I can imagine like, you know, we've had that so many times where you're literally on the phone with someone who doesn't speak English. So, you know, if this would be in a local language, this would be a huge, huge help.
That's a really good point. What's your top 3 to 5? If you had to pick. Aside from the obvious ones, because I think what you're calling out is there's a bunch of remote compute going in to now probably countries that may not be speaking sort of your standard English, Spanish, German, etc.
Exactly. So I don't know like what would be the top 3, but like, you know, I think when we were like, for instance, shipping stuff into China, you know, that was a challenge.
Mm-hmm.
But even in countries like France, like, you know, you just like getting someone who's locally in some like small village, not necessarily in Paris, but like, you know, some small village in the south of France, you know, and there's no like the remote hands who are available in there are not, you know, speaking language. So speaking English. So, you know, even French.
Spanish as well.
The toughest one are the ones where the language is different and all the signs are different, like Japan, where you have both different, then it becomes challenging.
Yeah.
Absolutely. Well, I think you actually bring up an interesting point, because the whole assumption of this is that these are not network people.
Mm-hmm. And that's the other thing. Yeah. Like, you know, when you're deploying switch in like, you know, local branch somewhere, there's like someone not technical and someone who doesn't speak English.
Absolutely. That's a really good call out. We absolutely do need to localize that. So let's go to the next step. If you're going to build a fabric, what would you need to do to it? So we have really powerful fabric technologies. Minako, you know more about ACI than about anybody I know. You've worked on it for about a decade now, right? Likewise, we also have solutions that are deeply built on EVPN VXLAN. There's a lot of tools in the toolkit that we can pull from to build this. But when we built it, we needed to do a few things. We needed to be something that you can easily deploy remotely. So I need it to be hardened. I need that switch that I ship out to always call home to cloud and not do anything else. I can't have a switch that pops up in a ROM mode where you have to go search the file system and find the right boot string to magically make it work. That doesn't work if you're shipping to a remote location and maybe you don't have a CCIE on staff. I also need something that I can automate easily. Right now, everything, especially a lot of these workloads that are coming back from cloud, they're coming back with an automation scheme from cloud. So being able to automate this by an engineering team that knows how to automate cloud, but may not be a set of CCIEs is important. If you're automating EVPN fabrics today, even if you have controllers and tools to help you, you have to think about how does this port map to a local VLAN, to an MVE interface, to a VTEP? What's reachability of VTEP? What's a VNI? How does that happen on the other side? Where does it gateway? That's exposed to the automation team. That's asking a lot of the automation team. If you configure a network in AWS, it's just a network. Why does it have to be hard? So we did need to think about the programming surface here as well. And then likewise, when you're building the fabric itself, one of the things we see is fabric technologies today are incredibly powerful. Every discussion you've had about them is about scaling them up, though. What happens when you want to take advantage of a fabric, but maybe you don't need that many switches? Wouldn't it be nice to have the ability to deploy an EVPN fabric where we can make it much more plug and play and flexible? Absolutely. But these are the things that we've considered as we started building this. So we had to build a lot of new components. I need a new switch that will call home to cloud. That switch has to be hardened, by the way. If this is going into remote sites, maybe it's not a fully secure environment. Maybe this is a shipping container sitting outside with a whole bunch of compute in it. I need that fabric to be something that is relatively hardened against attack. So I need integrity validation. I need hardware root of trust inside these boxes. I need to make sure that they always call home to cloud. Likewise, it may even be an untrusted environment. What happens if these switches are outside a firewall? I need to harden the surface of this device as well. So we've done that as well. That's what we've done on the hardware side. We've also taken standard EVPN VXLAN, but we've changed the way the control plane works so that it's actually plug and play. And I'm sure a few people out there that have built this by hand are calling BS on me right now, but we actually did it. And there's some key things we did to make this work. But the net effect is that what you can do is now deploy an EVPN VXLAN fabric that is plug and play, and you can even change the shape of that fabric in service without having to re-architect it. Fabrics today are too fragile. That's one of the key things we wanted to fix. Let's look a little bit more at what this looks like. So we've built a fabric. So we've gone through the configurator. We have a blueprint design. What's the next thing you want to do on a fabric?
Plug in stuff.
There you go. And then configure connectivity across it, right?
Oh, sorry.
Yep. Sorry. Go ahead.
Sorry.
Yeah, let's build a network.
Yeah, let's build a network. So the actual data center network deployment doesn't finish without a logical configuration, such as VRF, logical networks, Anycast gateway, and so on. In Hyperfabric, we don't have to care about the physical topology that much after our initial physical cabling plan. So let me hide this, and then let me create one logical network across these 2 span 8 switches. So let me create one logical network, and then it's pretty easy, and it might be too fast to create one. So let me create a second one, and then let me pause here. What configuration I just put?
Who here has done this by hand? Is anybody enough of a masochist to actually build an EVPN VXLAN fabric without a controller by hand?
In LEP.
Yeah, I think we've all done it. Some of us are a little weird, and yeah, you gotta want to go through it at least once. In order to get a EVPN VXLAN switch, it doesn't matter what vendor it is, you have to build out an underlying routing network, you have to sort out reachability, you have to set up a BGP mesh for EVPN, then you have to start to configure services, you have to sort out VTEP reachability, you have to define a profile for what this network looks like, what VNIs it is, and mapping. It's about 400 lines of config per switch before you forward a packet. How many lines of config was that?
Actually, it's not even a line. It's just a text. And then you can specify VNI, but similar to ACI, we don't necessarily care about it because it's automated. If you want to edit it, you can still edit it. And then let me actually make one of them as a layer 3, meaning Anycast distributed gateway. Of course, we support multiple VRFs, but let me just select the default VRF. Then I'm gonna just make it dual stack.
So I think it's 2025. It's been a rough year already. It's pretty short so far. But there's not really an excuse to not be fully V6 compatible. So as we were building this fabric, the directive was 100% V6 dual stack everywhere.
And can you repeat that for posterity? Just say the first part again.
It's been a really
It's
strange though.
2025. It's been a long year.
There's no reason for this not to be.
Thank you. Yes. There's no reason for things to not be fully dual stack V4, V6.
We have that on film now, so we're going to be showing this to a lot of other people in the industry who don't seem to get that.
I await the darts.
But I think the main reason was there was a lot of additional lines of code. People were kind of struggling, and then if it is that easy to add dual stack, yeah, then there's no reason to not do it, yeah.
Absolutely.
It was, I think in the past, mostly lazy admins and too much complexity, maybe, yeah, that stopped us, yeah.
Add of a new protocol
Yeah, that's fair.
because it works differently compared to number of levels.
Yeah.
What is the single best thing about V6, by the way? If you had to pick one thing they did in that protocol that's better than anything else, what would you pick?
They got rid of broadcast.
What's the other thing?
No NAT.
No NAT, so address space. My
Extended
favorite.
headers would be my actually preferred thing because it makes your protocol more extensible.
Y'all are too smart. I was trying to go for an easier joke. My favorite thing is actually link local addressing.
I hate it.
It's easy to hate, but what it does do is it's always there.
No?
It's self-configuring. And if you want to build something plug and play, wouldn't it be nice to not have to worry about an underlay addressing model ever again?
Resulting in a network having 4 different addresses, 2 I cannot control.
If you had to see it and deal with it. So what we've done in this fabric in order to make it plug and play, is all that underlay addressing is actually v6 link local. We do that so we can facilitate auto discovery, and our protocols are actually building all the reachability based on that. In fact, we went through and we rebuilt the entire EVPN stack so that it's v6 native. In fact, there is no v4 packet on the wire in Hyperfabric until you configure a v4 SVI.
Beautiful.
If you have environments that have a mandate for v6, it's done. It's ready. You can already prove that it's fully v6. We did it mainly because it saved a lot of work in the provisioning. We didn't want it to be fragile. So if we have unnumbered addresses on each individual link, I can move a link from any port to another port, and we just dynamically discover an adjacency, and I don't care what the address is because it's just link local.
And it's the underlay. You don't care about
Absolutely.
it.
And the other key part to making this work is, by the way, we've configured SVIs, L2 reachability. Have you seen any IP address configuration other than what you're exposing to the user at all? Have you seen BGP config yet? As an EVPN fabric, I assure you there's plenty of BGP in there. Have you seen AS numbers yet? If you wanted a fabric to just work, especially if you're deploying in a remote location, all you have to do is literally plug in switches. You have a plug and play EVPN fabric. And my abstraction model here is this looks like a big layer 3 switch. You created VLAN, layer 2 network. We called it layer 2 network because technically there's a VLAN in the switch and we didn't want people who knew too much to get really confused by what we're doing. But it's a layer 2 network, got an SVI on it, automatically configured, distributed any cast gateway. It's done. I need a fabric that gives you all the benefits of a fabric, but maybe in that remote location, you don't have a CCIE ready to pre-configure it for you.
And I think this lowers the burden for entry-level people. Yeah, it makes it more streamlined. And at the end of the day, they just care about the services that they expose. Yeah, the underlay is maybe a TAC engineer care about that, but the, let's say, average lazy admin, as long as it works, he doesn't care. Yeah,
exactly. The other benefit here is when you design an EVPN fabric, how many, we talked about if you took 5 CCIEs, how many different choices are there of how you would build that? You could choose different IGPs, you can have different addressing strategies, you have different strategies on what you use for reachability or VTAPs. There's lots of ways to configure this. What I want to do is make fabric technology something that's pervasive and always works the same way, because you don't, in your data center, you don't want your fabric to be a snowflake. You don't want to be the only one that has that one combination of features that nobody else actually has.
So out of the box. Out of the box.
Out of the box? Yep. The way it works is you can think of the underlay as a bubble. What's inside the bubble is ours. We auto-provision it. We don't leak it to the outside world, in fact. You peer the outside of the fabric with the rest of the world. You peer your VRFs to the outside world. You attach hosts into these networks. You can then peer this with other fabrics at layer 2. All of those features and functions work the same way, except what we're doing is we're hiding that underlay, and we're able to dynamically provision it. And we did actually have to write a whole new equivalent of an IGP underneath this to make this work. There's another magic trick here. I can take you from a leaf spine down to a full mesh with no spines in the same fabric, and I can do that in service. Try that with a regular fabric.
So now comes the controversial question, yeah? I guess customers will love this, but the value-added consultancies, yeah, they are kind of, you have done their job, yeah? So
not really. This is the crap work. This isn't the fun stuff. The fun stuff, all the interesting network problems, as you well know, are at the boundaries. Yeah. You're still configuring boundaries. You still integrate this with your network. What's different is now you're not actually integrating the underlay into the rest of your routing plan.
Yeah, that makes sense. But yeah. I would say a lot of, let's say, enterprise businesses can live with that and is happy, and their daily production work is totally fine without buying every day a consultant which has BGP special knowledge to let's say, configure little details in the fabric. Yeah, so
certainly. I mean, to be also to be perfectly honest, I work at Cisco. We make lots of great products. We're really proud of what we built in Hyperfabric, But this may also not be your fabric. This may not be your product or your use case. There are plenty of things that maybe you don't want to simplify it and you want those amount of knobs. So this is not here to replace existing products that we have. This is a new operational model for where this makes sense. So there are plenty of places where you do need low-level controls that are still there.
Maybe there are customers that have a large number of CCIEs which are doing this full-time all the time, and there are the shops where you have this one person that needs to manage everything and has also other responsibilities. Yeah.
You know, we were actually really worried about two things as we designed this fabric over the last 2 years. And believe me, we spent an amazing amount of time with real network architects. We have people that basically ran all of routing for very large SaaS companies, people that ran routing and networking for large commercial banks inside the United States, energy companies. The surprising thing was that was what we were expecting to hear two problems. We're worried about reducing the complexity and we're worried about cloud. Those two problems were not coming up. We have energy companies that are looking to do this even on their OT networks because simplifying the networks actually solves their bigger headache right now. I think right now what we're seeing is there is so much complexity in networking that sometimes maybe it does help to reduce some of it. And we were, to be perfectly honest, it's a legit question. I was worried about the same thing, and that's not what we were hearing from people in the trenches.
Agreed. Often a more simple design is also more robust. If you turn on all the nerd knobs, then you have to manage these details all the time. Yeah,
absolutely.
How about interoperability with other fabrics like NSXT?
Perfect example. So it's a fabric like anything else. So interoperability is designed to work just like another fabric. What would you do with another fabric? NSXT is a special case because that's an overlay, so I'll get back to that one in a second. But what would you do with a normal fabric? Well, normal fabric, you'd have northbound peering. Yep. Typically, you do layer 3 ports. You'd speak some dynamic routing protocol or static if it's a smaller environment. So we have that. We do the same thing. You just do northbound peering over L3. Hosts, you'd attach hosts. You could single attach them. Ideally, you're dual attaching everything, unless you're running VMware, and LACP is kind of a pain, but you'd want something like multi-channel link aggregation. We have that. We built it in, so we've got LACP port channels. It's multi-channel today. By the way, it's not VPC. We built it using native EVPN. There's more modern technologies that we took advantage of because we had the chance to rebuild this. Then you also need to do east-west peering. So how would you do that? Well, one of the common models, we spent a lot of time with our data center engineering TMEs, with TAC. What do? Build back-to-back VPC model, build a port channel, peer them, tag those links as a trunk, and use that for coexistence and migration. We're not that different. Now, the overlay is just a question of where you start peering, but again, I mean, it's just a standard fabric. Sorry, I interrupted you.
Sorry.
Too many good
Actually, I have another step to complete the configuration. So let me show you. So I just define logical network, but I haven't define who is going to belong to this logical network. It's most likely we will have trunk, multiple VLANs. So we need VLAN membership configuration. So let's say VLAN 10 is belonging to logical network 1 or something like this. So it's pretty much similar to existing VLAN to VXLAN ID mapping, but you don't have to deal with underlay. So what you just need is selecting a logical network, and you can simply define who is belonging to this logical network. So if you have just standardized switches, you can say all of the switches, Ethernet 1/1, if VLAN tag is 1011, then it's going to go to net 1. But in this fabric, let me actually select leaf 1 and leaf 2, Ethernet 1/1 to 1/3. If traffic is coming on these ports with this VLAN tag, it's going to belong to net 1. So probably people still need to understand what does VLAN mean, but it's pretty easy to configure because they don't have to deal with underlay and so on. So let me just create second things.
So as Minako does this, think about automation. When you're asking your automation team to write automated provisioning inside your fabric, what do you see here? You saw how easy it was to create a layer 2 network. It's just a layer 2 network. You don't have to give a lot of information. In fact, you could just give it a name. You map ports to it, and that's it. And even the way that we're mapping ports to it is designed to be very automation friendly. You can basically program that data structure directly. Everything you see here, by the way, is programmed directly and exposed via an API. So we have 100% API completeness with everything that you see. And as we ship this, we're going to ship this with Terraform providers, and we'll have Ansible playbooks coming shortly after. So this is also designed to be automation friendly, because what we're also seeing is that as these workloads come back from cloud, especially some of these edge compute workloads, some of the people automating this are more familiar with the cloud model. So it was really important for us to think very carefully about the APIs and the object models that we expose so that they are familiar to people, and we don't force them to understand gory details of how the network works underneath. In fact, there's 2 levels of abstraction that we built. The first one is at the network level. You can see that just through what Nako provisioned in just the basic networks. And then there's another level of abstraction at the physical layer. That's where we auto-provision the fabric. So you as a customer provision services on top, plug in cables underneath, and we automatically fill in the glue between the two.
So can, like, not that it would be like so important, but I'm just curious, like, so how is that communication like happening between this dashboard and your switches? Is there like netcon for?
Oh God, no.
No.
Oh God, no.
Yeah. See, I'm just curious. Like, I don't think it's important. That's the beauty of this one, right? Like, it's not really important, but I'm just curious, I guess.
Yeah, no, it's a really important thing. So let's actually cover a couple things. You're asking the harder question, which I'll answer in a second. Let's ask the obvious question.
Okay, let's do it.
How do we connect to cloud? So first of all, how does it work? So the switches have an agent that calls home to cloud. So this is pretty familiar. Anybody here used a Meraki device? Kind of similar, right? What you want is you want a device that you plug in, you feed it internet, and it calls home to cloud. That's a short answer. It's very survivable. The other thing is the protocol itself, we've designed to look exactly as much as possible as an actual web client. Why does this matter? Because the entire internet is designed to connect web browsers to servers. So everything that you would go through, any type of NAT, double NAT, carrier grade NAT, proxy servers that could be required to go outside on a management network, all of these are designed to work with browsers. We've designed our protocol to look at, act, and smell just like a browser. What it also means is that there is no more hard-coded IP addresses. Everything is an FQDN. We do global load balancing. We have a globally distributed front end that will automatically handle global resiliency for that connection for these upstream servers. That is all exposed basically as a TLS client, and it's a RESTful interface. Everything is just REST. REST with a published API model, and it's already published. We can share it with you.
And how you do the telemetry, for instance?
We do, but why would you have to configure telemetry?
I don't know, like, for the troubleshooting, like,
No, why would you have to configure? We know we need it. Yeah. Why do we make you have to do it?
Yeah, no, I don't want to configure it. I'm more curious again, like, at the back end, like, how do you do it? It's just me being curious.
Yeah, it's actually part of the protocol. So if you're going to build a system like this, one of the reasons why a lot of people will ask us, why is this brand new? Like, you built a new cloud controller, we have new set of switches, new operating system, new agents. Because if you make this work, the way it works is you need the ability to create a feature in 4 places at the same time. When I create a new feature on a switch, maybe like we started off building like a SVI for layer 3, that has a data plane definition. I have to program the ASICs to forward it. I have a control plane definition. I have to basically program the side layer to make that actually happen in the switch. So there's kind of a data plane and control plane component on the box. I also need an intent model in my controller to describe what is an SVI, and it needs an address and it has a certain schema. And then I also need to have a provisioning model that's common between upstairs in cloud and downstairs on the switch. And if I'm going to make this not a dumb product, I need to have a feedback loop with automatic telemetry. And I need to actually build all of those parts of the feature at the same time so that they all work together, because I need that full closed loop to build this control model. All of that is automatically built into the client. So we're able to, our engineers that are designing these features have control both upstairs and downstairs for doing that all at the same time. And because of that, telemetry is not an afterthought. Telemetry is actually a key part of every feature we build. And the controller itself has control to authorize the agent to go extract the type of telemetry it needs. And in fact, it's dynamic. When you actually go look at telemetry, it's actually dynamically turning on a real-time channel to uplift telemetry faster because you're looking at it. But that's our opinion of how we should do telemetry, is make it an intrinsic part of the product and actually have it controlled from above. There is no telemetry config because we should be doing telemetry, not you. The other obvious question, by the way, and I'm looking at the clock here and I want to be mindful of that as well. What happens if a data center network gets disconnected from cloud? I'm surprised nobody's asked me that one yet.
That was my I wanted to ask, yeah.
The short answer is the only obvious one. It keeps on working. So what we've designed here is that to get the behaviors we want to enable this through a cloud controller. The reality is we can never allow your data center network to stop working. So what happens first? The actual cloud connection itself is highly resilient. If it gets disconnected from cloud, any one switch can connect through another switch connected to cloud, which means my disaster recovery is I bring in a cell phone. It was actually, we were worried about wireless outside. That was our disaster recovery plan here too. Just tether on your cell phone and plug into one switch, and your entire fabric is up and running. That's number one. Always be greedy about getting back to cloud. The other part, though, is there is no critical path into the controller for operating your fabric. All of the control plane protocols run on the switch, and you can even unplug switches and rebuild your topology if you're disconnected from cloud and it keeps on running. That's what survivability should look like. The only thing that happens if you get disconnected is you queue up configuration changes, telemetry pauses until it reconnects.
I guess it keeps on working for as long as you have defined a policy and a topology, because otherwise you plug stuff and it's not just going to work magically. It assumes there is a topology already defined.
Absolutely, yeah. And for instance, you have to have switches admitted to the fabric first before they can connect. But in general, the whole point is it does need to keep on working, and we spent a lot of time focusing.
And you have to be a bit mad if you want to introduce major config changes during an outage. Yes.
Absolutely. But in the end, you always have a get out of jail free card. It's just a web connection going to a public front end. You can tether on your phone. And as long as you plug into one switch, your whole fabric gets online.
How much bandwidth is needed for this control plane?
That was going to be my next question.
We show you, it's actually pretty low. We spent a lot of time reducing the amount of bandwidth. It's kilobits. It's kilobits per second.
Nice.
It's not high. Yeah. So I'm going to end here because I want to be respectful of your time. You guys have asked me so many great questions. There's a couple slides we haven't got to. It's not a Cisco presentation if I don't show you hardware. So here it is. So we talked earlier about we have to have purpose-built switches for this. So there is a high-density spine-oriented device as well as a leaf-oriented device. These are actually running the same ASIC, and I don't care where you put each one. You can just as easily use that as a leaf as a spine. You can even put host ports, gateway ports, anywhere you want on the fabric. And the thing I will leave you with is we added one more magic trick, which is we scale down. You can support spineless fabrics. So the one thing we haven't talked about that I want to cover before we finish is where would you use this? Think of a place where, to get started, we can scale up. We can build huge networks. We'll do the math here for you. You can build a big network. But if you're trying to plug in and you've got 300 ports in a remote location, you probably, if you're deploying a typical fabric, you probably have more RUs of servers than you do switches. Now I can deploy a spineless fabric, and I can even do it with a single box. Think about that as an operational model. Drop ship it, plug it in, remotely manage it, and no additional hardware around there required. I'm going to stop there.
Thank
you for the opportunity to present.
It's like a Meraki data center, actually.